This is, for example, number 1 in section 3.6. I've been kind of recording backward. That's why you see the writing for example 2. But in this example, we have our function y equals f of x equals 2 times x to the third power. And they tell us that, hey, x is 4. So I think you're fine with that. We're starting with x equals 4, but what does the second part mean? Delta x equals 0.05. So if I explain this part a little bit, this means change in x is 0.05. So look, we started with x equals 4. Okay, the first x value, this is the first x value, but this delta x is telling us the second x value, okay? The second x value, I'll just go ahead and write this as x sub 2, is going to be the original x value plus that delta x, the change in x. So what's that going to be? The second x value that we can come up with is 4 plus 0.05. So the second x value is 4.05. So we have two x values, and part A is asking for delta y. What does that mean? Okay, so what's happening is x is changing. Okay, so I'm going to go ahead and try to explain what part A is asking. Okay, as x changes from x equals 4 to x equals 4.05, find the change in their y values. That's what delta y is. So x goes from 4 to 4.05. What are their y values? Because I want to know how much their y values changed. In order to do that, I'm going to go ahead and plug them in to the function. First, let me plug in 4 into the function. And that's the function, right? So I have to do 2 times 4 cubed. That is 64 times 2, 128. I need to also find f of 4.05. That is 2 times 4.05 raised to the third power. And I'm going to get a calculator for this piece. All right, so if I raise 4.05 to the third power first and multiply this by 2, I get 138.86. So take a look. We are ready to find the change in y. Delta y is approximately f of 4.05 minus f of 4, which we found above, right? So that's going to be approximately 138.86 minus 128. And that is, let me subtract, 4.86. 4.86. That's how you can find delta y. Delta y is approximately 4.86. As x goes from 4 to 4.05, y increased about 4.86. That's what part A was asking. Now we're going to find dy, the change in y, or differential of y, using a formula method for part B and C. So I'm going to add another page here so that I can do part B and C, okay? I should copy these. and go down here. And this is where I will do part B and C. Okay, so part B, they want us to find dy, which is f prime of x times dx. And I think we're trying to keep it general here. We're not talking about that given x and delta x because we're going to be using that for part C, but we're just, like in part B, we're just coming up with a general formula. So all I really need to do is find that f prime. What is f prime of x? Well, if f of x is 2x to the third power, f prime of x is 6x squared. So I can say that dy is equal to 6x squared times dx. So this will be the answer for part B. Now let's use this to answer part C. They want you to find dy using that given x and given delta x value. Remember, they said x is equal to 4. Oh, well, I have those right there. They said x is equal to 4 and delta x is equal to, or dx is equal to 0.05. So let's plug in those, oh, whoopsies. Let's plug in those two green highlighted numbers into our dy formula. Dy is 6 times 4 squared, because x was 4, times 0.05. So dy is, if I do 4 times 4, that's 16. 6 times 16 is 96. Multiply that by 0.05. dy comes out to be 4.8. So let's compare the answer that we got from part A. The delta y, see, I got freaked out because I saw delta y equals 8, but that's for example 2 that I worked ahead. But remember, when we use that first method of actually subtracting the x's, let me bring it down and show you how close we got. The actual change in y was 4.86. If we are using that dy, the differential formula, that answer we got was 4.8. So they're very close, right? So that's how you can answer this type of question. I think it was confusing because of all these new notations, but I hope you understand what we were doing for each part. So I do have another recording for example 2. So please go ahead and watch that one too, and you will have 2 homework problems similar to example 1 and 2 on your 3.6 homework.